Linear versus exponential project.
Linear growth problem. Taylor's mother promised her $5 for each chore she does. Taylor got to work right away and did 7 chores in total. How much money does she get? So here's our table with X as chores and Y as amount of money. And then we have 0 through 7 for the amount of chores she did for X. And then we have the multiples of 5 for Y. And then our next now equation is next is equal to now plus 5. The start is 0. And then our equation is y is equal to 5x. Okay, Taylor's chores graph. So here we have the graph with for the x-axis we have the number of chores, and then here's the y-axis with the amount of money. And then here we have our line. As you can see, it's in a linear equation. So my first prediction is if Taylor did 20 chores, she would have made $100. So what you need to do is you need to put it in equation form. So that would be y is equal to 5 times 20, because her start value is always going to be 5, and then she'll do 20 chores. And then if you do 5 times 20, you get 100. So she'll have made $100 if she does 20 chores. And then for my second equation, if Taylor made $65, then she would have done 13 chores. So what you need to do is you need to have 65 as y, and then you need to do 5 times is equal to 5 times x. So what you have to do to get x alone is you have to divide by 5 on each side, and then you get 13 is equal to x. Exponential growth equation. So Taylor's grandmother said she would double Taylor's money for each chore she does at her house. Taylor starts with $2 and does 7 chores. How much money does Taylor earn? So here we have our chores is x and our amount of money is y. So we have 1 through 7 for x, and then our starting point is 2 for y, and then we go on to 7 in our table. So our next now equation is next equals now times 2, and then our start is 2, because we do times 2 to get to the next number, and we start with 2. And then our equation is y is equal to 2 times 2 to the x. It's an exponential.
We don't have time to worry about crap like that.
Okay, so this is the exponential graph. And then for x, we have the number of chores, and then we have the amount of dollars for y. And then it's labeled Taylor's chores. That's the graph it's labeled. And then our first prediction is if Taylor does 4 chores, then she will make $32. So what you need to do is you need to do y is equal to 2 times 2 to the 4th, because you start with 2, and you need to do times 2 to get to the next one, and you need to do 4 chores, so x would be 4. So that would equal to 2 times 2 to the 4th is equal to 16, so that would equal to 2 times 16, which is equal to 32. So y is equal to 32. And then for our second prediction, if Taylor makes $512, very generous grandma, may I say, then she would have done 8 chores. So 512 is our x value, so we put our y value, so we put that right there. And then we do 2 times 2 to the x. So we need to divide by 2. That leaves us with 256 is equal to 2x, which is equal to 8.
Linear decay problem. In the tropical rainforest, there are 204 exotic birds that live there. Each year, 6 birds die. How many birds will there be in 5 years? Okay, and so the x value is the number of years, and we go from 0 to 5, and the number of birds is the y value. And then our next equals now is next equals now minus 6, and the start is 204. And the exponential equation is y equals negative 6x plus 204. Here's the linear decay graph, and the title is number of birds each year. And the x-axis is the number of years, and the y is the number of birds. And our first prediction, after 10 years in the rainforest, there will be 144 birds left. So since it's exponential, you do y equals negative 6 times 10 for the 10 years, plus 204, which is our start value. And then you do, and that's y equals 144. And then our second prediction, there was once 204 birds in the forest, and now there are 135, and it's been 11.5 years. And 135 would become our y value, and that would equal negative 6 times x plus 204, our start value, and you minus 204 from both sides, and get negative 69 equals negative 60 times x, and you do negative 69 divided by negative 6, and you do x equals 11.5. Exponential decay problem. In the tropical rainforest, there are 150 blue jays. Each year, the bird population decreases by 11%. How many birds will there be in 5 years? And our x value is the number of years, and the y is the number of birds. And our next equals now times 1/2. And the start value is 150. And our exponential equation, or explicit equation, is y equals 150 times 1/2 to the x power. Okay, so for our graph, the y-axis is the number of birds, and the x-axis is the number of years. And it's titled number of birds each year. For our first prediction, in 6 years there will be 2.34 birds left in the rainforest, and you do y equals 150 times 1/2 to the 6th power for the 6 years, and then you solve that and you should get y equals 2.34. And then for our second prediction, there are 16 birds left in the rainforest in 3.2 years. And you have to put 16 into the y value equals 150 times 0.5 to the x power. You minus 150 on both sides. And then you do 135 divided into 1/2. And then you take the 268 and square that. And you should get 16.37, and you round down for 60.
Okay, so one more comment. So on the first, don't look at me like that, Sarah. So on the first problem for the graph, I did not say the title, but there is a title. So if you do not believe me, you can feel free to go back and look at it, because there is a title. I did not say that. Yes. The end. We.